Today we discuss about remaining part of kinematics. So in the kinematics graphs, we discuss about graphs. So here there are three types of graphs are there. That is, first one is displacement, time graph. Second one is velocity, time graph. Third one is acceleration, time graph. So here we discuss about three types of graphs in different situations. Now we discuss about first graph, that is displacement time graph. Displacement time graph. In the case of displacement time graph, displacement is along y-axis, time is along x-axis. So this is the displacement time graph. So in the case of displacement time graph, first case is particle is at rest. When a particle is at rest position, so it represents displacement time graph is, so here displacement along y-axis, time along x-axis. So now a line, it is a straight line, is parallel to the time axis. Is parallel to the time axis. Okay. Next, case 2. When a particle is moving uniform velocity or uniform motion. So here uniform velocity means constant velocity case. So here in the case of displacement time graph is displacement along y-axis, time is along x-axis. So here in this situation, a line passing through the origin, it is a straight line passing through the origin. So in this situation, so here velocity is constant. So here velocity is constant. So in this case, the body is starting from rest position. Next, case 3. Case 3. When a particle is moving uniform acceleration. In this case, displacement time graph is this one. So this is the curve one. It is another one. So in this case, displacement along y-axis, time along x-axis. In this situation, the curve one represents the particle is moving in uniform acceleration starting from rest. Uniform acceleration starting from rest. In curve 2 represents, it is also a uniform acceleration but starting from some instant. It is also a uniform acceleration starting from instant. So it is not a rest position, it's some positions are travel. Next, case 4. Case 4. When a particle moving with uniform retardation. So retardation means negative acceleration. So in this case represented by the displacement time graph is, so here this one, in this case it's a parabola. So here in this case the initial velocity of the bodies are there, so but final velocity is 0. So in this case when the body is moving with uniform retardation, its slope is negative. Next, next case is when a particle is projected vertically upward motion. So in this case displacement time graph is represents, so its shape is this way. So in this situation, so here it's a maximum height. It is a maximum height. So its maximum height h equal to u square by 2g. It is the time of ascent. So that is u by g. So it is t2. Here t2 is treated as time of flight. Its value is 2u by g. Once again I want to repeat. So in this situation, so this is the maximum height. Its displacement is maximum. In vertical displacement is maximum. That is the maximum height. At maximum height u square by 2g. This point. So in this case, so this is a t1. Here t1 is equal to time of ascent. So time of ascent equal to u by g. So here this is the time of flight. So here t2 equal to 2u by g. So this is one of the example of vertically projected body case is represented by the displacement time graph. Okay. Next graph is velocity time graph. Velocity time graph. So In the case of velocity time graph, first case is particle is at rest position. So when a particle is at rest position, it represented velocity time graph is velocity along y-axis, time is along x-axis. So in this situation, velocity time graph is represented by the when a particle is at rest position, its a line is along the time axis. So this one, a line along the time axis. So here if you assume, so 0 meter per second, this is a 1 meter per second, this is a 2 meter per second, this is a 3 meter per second. So in this situation, in the along x-axis, times are 0 second, 1 second, 2 second, 3 second. So in this case, 0 second, that is a velocity 0 meter per second, 1 second, that is a 0 meter per second, 2 second, that is a 0 meters per second. So it means the body is at rest position. Next one. Next case is uniform motion. When a particle moving uniform velocity. So in the case of uniform velocity, velocity time graph is this way. So here it is a straight line is parallel to time axis. So in this situation, acceleration is equal to 0. So that means velocity is constant. So in this situation, here initial velocity is u. So therefore v equal to u plus at. So here a is 0. So v equal to u. So here final velocity is equal to initial velocity because of when a particle is moving in uniform velocity. Next one is third one. When a particle is moving uniform acceleration. So in this case, velocity time graph is represented by this is a straight line passing through the origin this way. So this is the first line. So another one is second line this way. So here these two lines, their first line is represented by the uniform acceleration when a particle is starting from rest. But in the case of second line represented by the, it is also a uniform acceleration when a particle is starting from some velocity. Starting from some initial velocity. Okay. Next one. When a particle is moving uniform retardation. Third one. When a particle is moving uniform retardation. So in this situation, velocity time graph is this way. So here its slope is negative. Its slope is negative. So here when a particle is moving with initial velocity some but final velocity 0. So this graph is represented by the uniform retardation case. So here acceleration is negative. Next one, when a particle is projected vertically upwards, when a particle is projected vertically upwards. So in this case, its graph is this way. So here in this case, this is the A, this is the point B. So in this situation, it is a vertically upward direction. So its velocity at maximum height is 0. So here A point is maximum height. So its velocity is 0. And then it returns to the earth surface. So this is the same projection point. So here this is the time of ascent. So this is the time of flight. So in the case of time of flight, 2u by g. Here it is time of ascent, that is ta equal to u by g. Next, next one is acceleration time graph. Acceleration time graph. In the case of acceleration time graph, first one is uniform acceleration. In the case of uniform acceleration, acceleration time graph, it is a straight line passing through the, it is a straight line parallel to the time axis. So this is a uniform acceleration. Next one is non-uniform acceleration. Non-uniform accelerations. In this situation, non-uniform acceleration, so its graph is in this way. So in the case of non-uniform acceleration, the graph shape is okay. Next one, some important note points are there. Important note points. Point number 1. So here it is one of the velocity graph, velocity time graph. So now it explains this situation. So here velocity is constant. So that means here OAB. So in this situation, OA line represents constant velocity, but Here AB line represents, it's a retardation. So that means negative acceleration. Because of its velocity is gradually decreases, its slope is negative. So but in the case of OA line, it is a constant velocity. That means when a particle is moving with uniform motion at OA line only. Okay. Next, note point 2. Note point 2. So here it is one of the velocity time graph. This is the O, A, B, C. So this graph, in this graph, here OA line is represents accelerated motion of the body. But here AB line treated as uniform motion. Uniform motion means constant velocity. So in the case of BC line represents uniform retardation. Okay, next one. Next note point is so here this is a speed and time graph. Speed and time graph. So in this situation, speed is along y-axis and time is along x-axis. So in this case, this graph is represented by the vertically projected body case. So in the case, the speed is gradually decreases. At maximum, its speed is 0. But and the other case, its speed is gradually increases. Okay. Thank you.